Hey, this is the part 2 of the video series on telemarks. In the part 1, we discussed what is telemark, we discussed about the definition of telemark, brief history of telemark, and we learned how to represent or write any natural number using telemarks. In this video, we are going to learn how to use telemark in our real life. Okay, and we'll learn this using a frequency distribution table. Now, if you're not aware of this frequency distribution table, then don't worry, it will get clear to you with this example that we are going to discuss. So I have already drawn this table here, and actually let's suppose that the class strength of your class is of 50 students. Okay, you have 50 students in your class, and there is a sports event that is going to take place in your school or college, whatever. Each student has to take part in one sports event, not more than one. Each student has to take part in one sports event only, and they have to take part, that's mandatory. And your sports teacher asks your class teacher to make this kind of table where there's serial number and there are list of events, and you have to tell the number of students taking part in each event. Okay, this is the condition that 50 students are there. One student can take part in only one sports event, and it's mandatory to take part in sports event. No one can skip the day, and you have to prepare this table, and you have to tell the numbers of high jump, for long jumps, the number of students taking part in these separate events. Now, how can you do this? You have 50 students. Okay, so if you suppose you ask that, your class teacher asks that, okay, how many students are going to take part in high jump? So let's suppose that either students stand up at their place or they raise their hands, and then you start counting, right? So 1, 2, 3, 4, and so on. That can create some mistakes or some errors in counting. What can be the best way? The best way can be like, the teacher can ask that, okay, I want to know how many students are going to take part in high jump, and when they raise their hand, what teacher can do is start using the telemark or the not vertical strokes, that is telemark, and then count and then tell the number. So let's say that she asks the enrollment number 1. Let's suppose that every student has their enrollment number, and starting from the first enrollment number, the teacher asks, okay, enrollment number 1, in which event you want to take part? So enrollment number 1 says that I want to take part in long jump. So let me take with some different color, Control Z. So this long jump. Enrollment number 2 says 200 meter. Then for 3 says high jump. Then 4 says long jump. Okay, the enrollment number 5 says long jump. 6 says long jump. So 1, 2, 3, 4, 7. Let's suppose the 7th also says long jump. So the 5th diagonal will be in this way, and that we know that. Okay, then the 8th one says I want to take part in hockey. Okay, the 9th one says I want to take part in 100 meter. The 10th enrollment number says that I want to take part in 400 meter. So after asking starting from 1 to 50, let's suppose that we have this scenario that I'm just going to write down here. So this is the final telemark result that your teacher writes down here. Now if you have to tell the number, this is 5, right? We know that the clustering of telemarks is done in a number of 5. So this is 5 plus 1 is 6. So the number is what? 6. This is 5 plus 5 plus 5, that is 15. 5 plus 5 plus 5, that is 15. Then this is 5. Then this is 5 plus 2, that is 7. This is 2. So 15 plus 15, 30, 36, 41, 48, and 2, 50. So for every student, your teacher has actually made this, she has prepared this table, and where this particular column, that is the number 1, is actually telling about the frequency. That's the outcome, that's a number, that's a count that we want. That is what actually frequency means. Okay, so she has to tell the teacher that how many students are taking part in each sports event. So this telemark she used for her help to make a proper count of this particular columns without any error, okay, and without any confusion. So she used a telemark representation to avoid any kind of error or confusion, and then she can finally count these telemarks and then can tell the number. This is a frequency distribution table because this particular section or the column is telling about the frequency, that is the number of count or the number of occurrences or the frequency of what we want, of the number of students taking part in each event. So this is what the frequency distribution table is. Okay, so this is one of the use of of telemarks, that how we use telemarks in some real life example. So those of you who haven't watched a part 1, please watch that part 1 video. That's very important because we have discussed the basics of telemark, that how do we group or cluster these telemarks into group of 5. Okay.